Alrighty, so we're going to continue our adventure through these trickier sort of trigonometric questions with some applications. And let's have a look at another example. So, Toy's blood pressure, P measured in millimeters of mercury, mmHg, at T minutes after arriving at the doctor's surgery can be approximately modeled by P equals 90 minus 10 cos of pi t on 15, where 0 less than or equal to t less than or equal to 30. Determine the amplitude and the period of the function. Amplitude's easy. It's 10. Period's a little bit more interesting. Period is equal to, well, it's a cosine function, so it's 2 pi over the absolute value of b. And in this case, b is pi on 15. This might be a little bit tricky for some of us, but we've been working with these things for a while. So we multiply it by 15 over pi. The pi's cancel, and we get 30. Important to kind of have an idea of what we're interested in. So this would be like 30 minutes, right? Because that's what t is being measured in. Alrighty. Similarly with the amplitude, we can think of it as millimeters of mercury C. So that's mmHg. Hg is the chemical, the periodic table lettering for mercury. Strange, but you know, these terms have been around for a long time. So that's part A done. Let's have a look at that. Sketch the graph P for the first 30 minutes. Alrighty. So that means we've got a cosine function. It's got a negative, and it's going to repeat after 30 minutes. There's no phase shift in it, so it is going to start at the usual point for a cosine function. Alrighty, so on this axis we're going to have P, and on this axis we're going to have T. 30, half of 30 is 15, half of 15 is 7.5. Halfway between 15 and 30 is going to be 22.5. So there's my x-axis and my y-axis set up. I know that the maximum value is going to be 9. So this is the interesting part. It has been a reflected function. Meaning it's not going to start at the maximum, it's actually going to start at the minimum, with the median halfway in between. Now the median is quite easy to recognize. The median is just going to be 90. The maximum is going to be 10 above that, so it's 100, and the minimum is going to be at 80. Now because it's negative, it means that it's been flipped, meaning instead of starting at the top here at 100, it's actually going to start at the bottom here at 80, and it's not going to repeat until we get to the period, which is 30. Which means at 15 it's going to be at its maximum, and at 7.5 and 22.5 it's going to be at the median. So there's my sketch of the function for the first 30 minutes, t up to 30. Alrighty, so the first question is, when does Toy's blood pressure first reach a reading of 85 millimeters of mercury? So that's what mmHg means. So for C, it's asking, when does P equal 85? Well, there's two ways we could solve it. Graphically, we could try and solve it using our calculator, but let's try and avoid using our calculator. So P equals 85, that means we get 85 is equal to 90 minus 10 cos 15, pi x on 15. Alrighty, so first of all, let's subtract 90 from both sides. We get negative 5, negative 10 cos, and divide both sides by negative 10. You get a half. Alrighty, and so then let's do a substitution. So theta equals pi x on 15. So we get a half, or cos theta equals a half. When does cos theta equal a half? Well, there's a few solutions, but let's just take the first solution we can think of. And the first solution is going to be at pi on 3. But remember, we weren't solving for theta, we were solving for x. So, undo our substitution. Pi x on 15 equals pi on 3. We can multiply both sides by 15, divide both sides by pi. We get x is equal to pi divided by pi. And 15 over 3 is 5. So x equals 5. Now if we have a look at our graph, that looks pretty reasonable because we can see that by 7.5, it has already reached the median line. So we'd expect it a little bit lower to actually reach that 85. So the gut check is working out. Alrighty, so part D asks us, for how long is Thoy's blood pressure higher than 85 millimeters per millimeters of mercury? The MMHG is really messing with my head today. Alrighty, so we've already worked out that at this point here, let's do it in red, right? At about 5, it hits there. And so then we recognize that at a certain point over here, it's going to do the same thing. Now, this is a symmetric function, right? So if it takes from 0 to 5 for it to reach 85, we'd expect on the far side for it also to be off by 5. 5 off 30 would be 25. And by symmetry, we know that in between 25 and 5 is where it's going to be hitting. So for part D, 25 minus 5 equals 20. Therefore, for 20 minutes. His blood pressure will be higher than 85 millimeters of mercury. Alrighty, so the last part, part E, is determine the rate of change of Thoy's blood pressure after 5 minutes. So for a rate of change, we're going to need to take a derivative. So for part E, we're interested in what's the rate of change, dp dt, oh sorry, dx. Oh no, yeah, it is dt. I don't know when my x's all became, when my t's all became x's. It's just out of habit. Let me just go back and fix up all of these. It's a habitual thing that we deal in x's and y's and thetas. So every so often, you can find yourself just getting lost up in the excitement. So it's dp dt. And we're interested in that when time is equal to 5. Alrighty, so let's write down our p function and then take the derivative. Alrighty, so the derivative dp dt, well, the 90 derives to nothing, the negative 10 stays, cos goes to negative sign. But then we also multiply by the derivative of the brackets, which is pi on 15. It's pi on 15 times t, so the derivative of pi on 15 times t is just pi on 15. Alrighty, so let's do some simplification. We've got two negatives, so they're going to cancel out, and then we're going to get 10 pi on 15 sine of pi t on 15. 10 on 15 simplifies to 2 on 3. And there's our final simplified version. And now all we need to do is substitute in t equals 5. So now we just need to work out what this is equal to. So we've substituted 5. Well, 5 divided by 15 is just 3. Pi on 3, so the sine of pi on 3 is root 3 on 2. The 2 and the 2 cancel, and we get root 3 pi on 3. And that would be our rate of change. Obviously, we'd probably want to know what this is as an exact value. And in this case, it's approximately equal to 1.81. And that is milligrams of mercury per minute, based on our units of measurement. Alrighty, so that's another practical example, doing a bunch of the things we've been trying to do: sketching, solving, using our symmetry, interpreting, and taking derivatives. So we're trying to do a bit of jack of everything. You can see how it all joins in together. Alrighty, I'll see you in the next one. Goodbye.